My name is Pearse Keane, and so I'm a consultant. I wear a couple of different hats, but I'm a consultant ophthalmologist at Moorfields Eye Hospital in London. And so at Moorfields, I specialize in the treatment of diseases affecting the back of the eye, things like diabetic eye disease and age-related macular degeneration, some of the commonest causes of blindness in the UK and around the world. And the other hat that I wear is that I'm a professor of artificial medical intelligence at the Institute of Ophthalmology at University College London. And although I'm not a computer scientist, I'm not an engineer, I've somehow come to find myself leading a multidisciplinary clinical research group that aims to develop and apply artificial intelligence in healthcare. And that's in ophthalmology, but not limited to ophthalmology.
And that's why I'm so interested in what you do. So tell me, Pearse, have you always been a bit of a techie?
I can remember getting a Commodore 64 back when I was 8 years old, 10 years old, living in Dublin in Ireland at a young age and beginning to learn how to program that in a kind of limited way. And then I think for me, what happened then was, I guess, like a lot of middle class kids who are good at school in many countries, drifted towards studying medicine, went to medical school in Dublin, and somehow kind of got into this very focused medical world and didn't really have as much time to focus on computer science or engineering or all of those other cool things, but always had half an eye on what was cool in the tech world and what was exciting, but more as a kind of a hobby. And then what happened was I went to the US, to Los Angeles for a couple of years to do some training when I finished my medical school in Ireland, and then moved to the UK and really started to think about setting up my own research group. And really what I wanted to do, or that the central idea for my research group was, can I identify cool stuff in the tech world and see if there's an application for that in healthcare? And that could be virtual reality, augmented reality, smartphone applications, blockchain, dare I mention that, or it could be deep learning or artificial intelligence. And so, I mean, that's essentially the background to where I am today.
And we can guess that what you centered in on was deep learning and artificial intelligence because you had an involvement with DeepMind, one of the leading pioneers of AI, didn't you?
So I think what was happening was that back around 2013, 2014, 2015, I was reading about and getting very excited about all the advances in artificial intelligence that were occurring, in particular the way deep learning was really kind of reinventing the tech industry. And reading these articles in the New York Times called The Great AI Awakening and things like that. And so I guess immediately I realized that could have a lot of healthcare applications, and particularly could have a lot of applications in ophthalmology, my own medical specialty, because it's so driven by imaging. And so at that time, I was reading about deep learning and I was reading these articles saying that, you needed like world leading technical expertise, you needed like world leading computing resources, and I was thinking, how the heck do I get involved in a project like that? And so I went to a number of people in an academic, in a university setting who had some knowledge of this area and approached them about potential collaboration. And to be honest, was met with shoulder shrugs to a large degree. And then I was thinking, okay, maybe I have to collaborate with industry. And so I was thinking, who can I contact? I can't send an email to Bill Gates or something like that. But what's the right level of seniority and expertise? And so the eureka moment for me was in I think about July 2015. I was reading Wired UK magazine, and there was a big profile of DeepMind, and essentially it was just one of those. It was just so exciting to read about read about what they were doing and all the work they were doing in Atari video games and so on. But then the really kind of eureka moment for me was there was a part of the interview with one of the co-founders of DeepMind, Mustafa Zilliman, and he said, you know, we want to take our technologies and use it for good. So we want to use it in healthcare, in climate change, in energy consumption, in science, etc. And then, of course, in the interview, they also talked about the links that DeepMind had with London, the fact that 2 of the 3 co-founders were graduates of University College London, which of course is the university affiliated with Moorfields. And I thought this is the person to contact, Mustafa Zilliman. And so I tracked down his profile on LinkedIn, and I actually took out a 1-month premium subscription on LinkedIn so that I could send him a message without being directly connected to him. And
you were determined.
So exactly, but it just felt like really, I mean, maybe I get overexcited, but it felt like a magical moment for me because, or it felt like a perfect opportunity. And so I remember spending like a couple of hours trying to compose just like a 1-paragraph message, which effectively said something like, you know, I'm a consultant at Moorfields, an ophthalmologist. You know, there are people that are going blind in the UK and going blind around the world because of delays in being seen and treated. And one of the challenges we have is that we're generating huge amounts of ophthalmic images, these retinal scans called OCT, or optical coherence tomography scans. And we don't have sufficient people with the expertise to be able to interpret these scans. And so, you know, can we work together to develop a deep learning system that can actually identify those patients with the most sight-threatening disease to try and get them in front of someone like me to receive treatment and thereby save sight? And by the way, we're 2 stops away from you on the tube. And so, to my joy, and I guess, you know, life-changing in many ways result, he sent a message straight back to me and said, come and meet me. And you know, a few days later, I found myself in his office discussing the collaboration.
And then let's leap forward, because that exact challenge that you outlined to him is the great project that you have been involved with ever since. Yes. Is that right?
Yes. So, so little did I know what I was embarking on, but that was July 2015, and we're still working on that challenge now and making, I think, really exciting progress in this. But essentially, the first step that we had to do was think about what's the best way for an NHS institution like Moorfields to collaborate with a commercial partner like DeepMind, an industry partner, particularly given the fact that there would be appropriate sensitivities around the fact that the parent company of DeepMind is Google or Alphabet, and that this would involve sharing NHS data with the commercial partner to develop an AI system. And so we put a lot of thought into making sure that we did everything very nicely and very correctly from an ethical and a data protection perspective, and everything correctly in terms of getting appropriate value back to the NHS for the data that is generated. And then also in terms of the way that we approached patient and public involvement and engagement. So one of the things that we did was that even before we started any actual experiments, we brought on board the Royal College of Ophthalmologists. We brought on board all the major eye disease charities. We brought on board a lot of our patients with the retinal diseases that we were particularly interested in helping. And we tried to tell people at Moorfields what we're doing. So we have a section of the Moorfields NHS website, which is dedicated to collaboration, which is still there. We have posters around the hospital. In some of the waiting rooms, on the screensaver, on the TVs in the waiting rooms, occasionally something will come up saying, you know, here's the Moorfields DeepMind collaboration. If you want to know more details, you know, here's who you contact, et cetera, et cetera. So I think we really worked a lot and thought a lot about how to do this in such a way that it could be kind of like the gold standard for these types of collaborations. And so then that led into the actual science. And we worked for a couple of years in making a world-leading algorithm. And so in September 2018, we published in the journal Nature Medicine, we published a proof of concept of what we had achieved.
Let's just step back for one moment to stress again what the challenge is, the sheer volume. Tell us about these eye scans, how many of them there are, and why that presents a huge challenge to the NHS, particularly at the moment.
Well, I think maybe just before I answer that, just to give you one additional kind of broader context about the challenge. You know, the fact is that people don't realize just how busy ophthalmology is. And so since 2017, ophthalmology has actually overtaken orthopedics as the #1 busiest of all medical specialties in the NHS in terms of clinic appointments. So nearly 10% of all clinic appointments across the NHS are for eyes, and that constitutes nearly 10 million appointments per year. And to put it in a brutal way, we are drowning in the number of patients that we need to see. Now, that's one thing. Now, the second thing which you just referenced was ophthalmology is so imaging based. We do huge amounts of these images, and in particular, these images that I mentioned called OCT, which is optical coherence tomography images. And that's kind of like an ultrasound of the eye, but instead of measuring sound waves, it measures light waves, and it gives us really high resolution images, so much higher resolution than an MRI or a CT scanner. And the fact is that at Moorfields, we do more than 1,000 of those OCT scans, these retinal scans, every single day. And so you can imagine that's a huge challenge to be able to assess and interpret those images. And so it seemed to me this was a perfect use case for artificial intelligence, in particular deep learning, which is basically to be able to look at these retinal scans and identify those patients with the most sight-threatening types of diseases and prioritize those sorts of patients.
Because to be clear, every modern optician on the high street, optometrist on the high street, has one of these machines, and therefore they are pumping into the system more and more patients who might have this sight-threatening condition.
So this is the issue. So if you go to any of the major optometry chains or independent optometrists now, you'll very often be offered to have an OCT scan done as part of your sight test. And I think that that's a really good thing. Let me be clear, I don't want to seem negative about it. On the other hand, it's a little bit like, imagine if every GP in the country was given their own MRI scanner, but they weren't necessarily given, or all of them didn't have the training to be able to interpret the scans, shall we say. And essentially every person who had a cough or a headache or something had an MRI scan done by their GP, you could imagine that the system would become overwhelmed. And in some senses, that's the challenge that we faced with ophthalmology. And so to make that sort of real, just one example back from when we were starting the collaboration, in 2016, Moorfields had 7,000 urgent referrals from optometrists as possible age-related macular degeneration. Now, of those 7,000 urgent referrals, only 800 of them actually had the severe form of macular degeneration that requires urgent intervention. Now, the problem then is that when we get those referrals as possible AMD, the Royal College of Ophthalmologists says that those patients should be seen and treated within a 2-week period. Now, as a person making these referrals, you may think you're doing the best thing for your patients by saying, you know, see urgently, possible AMD. But the fact is, it's kind of like the boy who cried wolf, because when you have so many that aren't, we don't always get them seen and treated within a 2-week period. And so really, to me, that actually perfectly embodied what we want to achieve in developing this AI system.
So you presumably, to develop this system, fed the machine, DeepMind's machine, with a zillion images marked up?
So essentially, the essence of deep learning is that you use these things called artificial neural networks. And the key feature of these is that you don't pre-specify the features to be looked at. So for example, pre-deep learning, pre-AI, the way that you would, if you wanted to develop a computer program to recognize a photograph of a cat, you would, in code, you would describe the features of a cat. Some cat have tails, some cat have whiskers, some cats are ginger, et cetera, and you would describe exhaustively all the features of a cat or whatever you're interested in. Now, of course, the problem with that is that that didn't really work that well, no matter how, decades of effort were put in. And the key difference with deep learning is essentially you just show thousands or maybe hundreds of thousands or even ideally millions of photos of cats to a neural network. And you just present the pixels to a neural network and say, this is a cat, this is a cat, this is a cat. And you do that millions of times. And essentially it learns then how to recognize a photograph of a cat. And if you can do that with cats or dogs on the internet, then you could do that with retinal scans. You can say, this is macular degeneration, this is macular degeneration, this is diabetic eye disease, and repeat as many times as you can. And then amazingly, if you've done it right, potentially you can have a system that's as good or better than world-leading experts.
And is that what you, in 2018, delivered?
Yes. So in our paper in Nature Medicine, we described an AI system that was on par with world-leading experts from Moorfields in assessing more than 50 different retinal diseases on these OCT scans of the retina. And for us, that was the kind of jaw-dropping moment in translating this technology.
So here's the big question. That was 2018. We're now in 2022. Is this system in action?
So the short answer is no. And I think what that speaks to is the much longer process in going from an idea to an algorithm is kind of in some senses easy in some ways compared to going from code to clinic to actually widespread implementation. And so essentially there's lots of different things we need to do. So you need to take the piece of experimental code that was that broke the records in Nature Medicine, and we need to make that into something that can be deployed at scale. So it's like as if the analogy I would use is imagine we're building a prototype car to break the world land speed record, and the Nature Medicine paper is we've broken the record, but we've done it with this one-off prototype that has a team of 20 or 30 engineers ready to tweak it for that record-breaking run. But now we need to think about how do we take that prototype and turn it into a production car that can be used safely and effectively by people all around the world.
Is there a lot of bureaucracy to get through and a lot of people not quite seeing the urgency?
The fundamental point is that this is a new technology, and that despite all the hype around AI in the context of healthcare, in the context of self-driving cars, in the context of other things, it's still in the early stages. And so we're very aware that it has huge potential, but at the same time, it has to be implemented in a cautious and safe way. And so we don't want to rush out anything in the context of for direct clinical care until we've made sure that it's safe. So for example, we need to make sure that the algorithm is clinically valid. So what we've described in the initial scientific publications is showing that it works on a large data set from patients at Moorfields. But what we're doing now is a global validation study. So actually, we want to prove that if you're a patient with diabetic eye disease in Ghana, in Brazil, in Mexico, in the US, in India, or in other countries around the world, that essentially the algorithm will work just as well on you as if you were a patient in Moorfields. So we need to do that clinical validation. And so there's real risks that if we don't get that right, we could disadvantage certain groups. And so we don't want to develop an AI system that only works on kind of white Irish people in their early 40s, for example. So that's one aspect. I think the other aspect is the technical maturity of the algorithm. So we need to be able to take an algorithm and make sure that it can be run with a fraction of the computing power in a fraction of the time as whatever we've initially developed, and that it's done in such a way that you have all the appropriate good manufacturing practices and good industry practices around the way that the code is built. And so that takes a lot of time and resources. And then ultimately, before you can use algorithms for direct clinical care, in most cases, you need to have regulatory approval.
The $64 billion question, as it were, how many years? When do you think it might actually be used?
So I think that this is coming sooner rather than later. And so I think that my prediction is that this is in the next couple of years. So I don't think that this is a 5-year plus time horizon. I think that this is a more like 1, 2, or 3 year time horizon to actually see this being used by millions of patients around the world. And I still, I'm an eternal optimist, but I genuinely believe that this could be one of the first autonomous AI systems to be used by millions of patients around the world. And for me, I feel very proud that Moorfields and the NHS and the UK could play a central role in that.
Well, maybe we'll come back to you in a couple of years' time and see if it's worked. That's a really exciting story with a certain amount of frustration, which I'm sure you feel, about how long these things actually take to put into practice.
But it takes time to do it right.
Pearse Keane, thank you very much indeed.